Lecture 8, Module 2, DMAIC Improve Stage 1. Select Solutions, Other Approaches. In this module, we'll look at data mining. We'll look at checking our assessment criteria, the Pugh Matrix, and solution screening. Data mining. Why do studies and collect data when you may already have the data stored somewhere? Years ago, the pharmaceutical industry was relatively simplistic when it came to technology, and sources of information really were quite limited. Today, many pharmaceutical companies have installed sophisticated computerized equipment that creates and stores valuable data on many different pharmaceutical operations. Unfortunately, the pharmaceutical industry has been focused more on finding ways to comply with Part 11 than in finding ways to retrieve information from their systems, but it is quite doable. Data mining can be used to study transactional databases such as SAP, data warehouses, relatively small local databases, all the way down to simple flat files like Excel. Some examples are the flat files, such as Excel spreadsheets, are by far the most common data source for data mining. Flat files are simple data files in text or binary format, and they're very easy to analyze. The data in these files can be transactions, like for instance manufacturing orders, or time series data, online measurements for some things coming out of tablet presses, anything. And then there's relational databases. These consist of sets of tables containing either values of attributes or values of attributes from relationships. These tables have columns and rows of data that can be queried. Some common database management systems are Oracle, IBM, DB2, Microsoft SQL Server, PostgreSQL, MySQL, and many, many others. Data warehouses. A data warehouse is a repository of data collected from multiple data sources, several different databases, and even flat files, and accessed by possibly many users. A good example of this is the Business Warehouse, or BW, for SAP, an example of which is on the left. The data pulled into the data warehouse can be pre-selected so that only the data you are interested in is pulled into and is housed in the data warehouse. The data warehouse allows you to analyze data from different sources all at once. And on the left, we see the business warehouse pulling information from SAP, Documentum, TrackWise, sucking in information from flat files, two different flat files, all by the SAP number. Generally, data mining in databases and data warehouses requires an understanding how databases are constructed and some basic knowledge of the SQL Query Language. But this is relatively easy to learn. Data mining will become a major source of actionable information in the future, especially for Six Sigma programs. Learn it. Assessment criteria. Once you've analyzed and explored possible solutions, it comes time to decide your course of action, and this may be the hardest step in the process. Since you are on a team, there will be different opinions on what direction to go in and which solution to choose. You will need an objective means of deciding to prevent dissension on the team. Assessment criteria. Have your team brainstorm to develop a list of the most important criteria for selecting a solution, like cost, time to complete, complexity of solution, etc., and select all the most appropriate criteria. Then have each team member assign relative weight to each criteria shown below. Clearly here the team agrees that solving the problem completely without any FDA issues is the most important. So we see all these characters rated at 20, 30, 25, 30, 35, higher than all the others with a weighted total of 140. Most important, no FDA requirements. The Pugh Matrix. This can be used to both select a solution but also to refine each solution so that the best solution can be developed. The Pugh Matrix works by comparing all solutions to a selected standard solution. Solutions may be combined later on to achieve a better overall solution. So select your solutions, the criteria, and the weightings. Then pick one of your solutions to become your standard. So in this case, we're picking a solution number 1. It will be the standard by which we'll compare to all the others. Then we compare each solution against the standard as either better, plus, the same, S, or worse. We add up all the weights and the calculations, and we calculate the weighted sums for each one of them. So here we see solution 2, the weighted sum of the positives is equal to 5, the number of sames is equal to 1, and the weighted sum of negatives is -5. Pick the strongest solution and then look for opportunities to combine the best features of them together into one super solution. For instance, maybe because of the weighting, we pick solution 3, And then we see that it's lower in completely solving the problem than the others, or for instance, solution 4. Solution 4 is better at completely solving the problem. So we don't just pick solution 3 and stick with it. It might be a good idea to use solution 3 and then look to solution 4. What are the things about solution 4 that make it better than solution 3? And then try to bring them into solution 3. That way you wind up with the super solution. Checklists. At first glance, it may seem like a grade school level idea to use checklists as an approach to such a project management, statistically based, high-powered technique such as Six Sigma. You might not think so after you hear this story. Central Line Catheters are catheters placed in a large vein in the neck, chest, or groin in intensive care units. Nosocomial infections, also known as hospital-acquired infections, from central line catheters are one of the deadliest and costliest types of hospital-acquired infections. They account for 80,000 infections per year, which account for 28,000 deaths per year, for a total cost of $2.3 billion a year. Definitely a Six Sigma type project, just based on the number of deaths. The Michigan Health and Hospital Association tried an experiment using a simple checklist to bring down the rate of infection. The simple checklist, designed by Dr. Peter Pronovost of Johns Hopkins University, there's a good university. I can't come up with any better than a checklist? Well, let's look at it. 1. Wash your hands. 2. Cover the patient with sterile drapes. 3. Clean the skin with chlorhexidine antiseptic. 4. Do not insert catheters into the groin area, where it's more likely we'll pick up bacteria. And lastly, remove the catheters as soon as they are no longer needed. 3 months after implementing the checklist, the median rate of infection was 0 and remained there for the 15 months of the study. This study was published in the New England Journal of Medicine. The Michigan Health and Hospital Association took a similar approach with ventilator-associated pneumonia, with nearly identical results. Moral of the story: simple solutions can be as powerful as high-tech solutions. Follow up to this story. In 1847, Dr. Ignaz Semmelweis demonstrated puerperal fever, also known as childbed fever, a form of septicemia, could be dramatically reduced by doctors just washing their hands with a solution of calcium hypochlorite, or chlorinated lime, before examining pregnant women. By the way, at the time, doctors examined the women after doing dissections on cadavers. Now, in the 1800s, people were not dying of Alzheimer's, they were dying usually of acute infectious diseases. And these doctors would examine people who had died of acute infectious disease and get that all over their hands, and then go examine women who were pregnant. As you can see, puerperal fever, the percentage of patients who died of puerperal fever in 1842, around November, December, was over 30%. So you had a 1 in 3 chance of dying if you were pregnant going into the hospitals of those days. After Ignaz Semmelweis implemented his chlorine hand wash, we see around March of 1848, the death rate fell to 0. Clearly spectacular results. He's a hero, right? Unfortunately for Semmelweis, and countless others, his discovery was ignored, dismissed, and even ridiculed by his contemporaries, as it conflicted with their current views on the causes of disease. He was eventually fired from the hospital for political reasons, harassed by the medical community, and finally committed to an insane asylum in 1865, where he died 2 weeks later from, quite ironically, septicemia. His discovery was not accepted until after Louis Pasteur convinced the scientific community of the validity of the germ theory of disease, also around 1865. Solution screening. Using the tools shown above, as well as others, all potential solutions should be screened against the basic requirements set at the beginning of the Six Sigma project in your project charter. It does not make any sense to find out after implementing your solution that you worked so hard on for months to develop that you overlooked one or more of your original goals. Make sure your solution matches your charter. Your management will find that hard to understand also, that you did not meet your goals and came up with a solution that does not meet them.